Hi, welcome back. Today we're going to look at section 5.4, which is on the fundamental theorem of algebra. So we're going to go over a couple of theorems and some steps on solving these, and then we'll look at some problems. So the first couple pages, you're going to notice a lot of boxes with a lot of information. So we're going to go through those, make sure that these make sense to you, and then we'll get going on some of the problems. So this fundamental theorem of algebra, which is kind of the basis of everything polynomials, says that for every polynomial that you're given, as long as a polynomial has a degree of 1 or higher, then you will find at least one zero, okay? Which, remember, that means where it crosses the x-axis. So this is just saying that any polynomial you have, so x to the first, x to the second, x to the third, this is the degree, then you will be able to find at least one zero, okay? Then we also have with that what's called the number of zeros theorem, which says a polynomial can have no more zeros than its degree. And hopefully you've already been realizing that as we started off with quadratic equations. Well, actually we started off with linear equations. A line will only cross the graph or the x-axis in one place, so it will only have 1 0. Quadratic equations, which are the parabolas, remember, they cross the x-axis no more than 2 times, so that would be 2 zeros for a second degree. Now remember, you don't have to have that many zeros, but that's the most it can have. Okay, so that's important. You can always have less than that, but not more than the degree. All right, and then the last theorem on this page talks about turning points. So it says if f of x represents a polynomial of degree n, then the graph of this polynomial will have at most n minus 1 turning points. Okay, so think about that. So if the polynomial is of degree 5, then it would only have at most 4 turning points. If the polynomial is degree 2, then you can only have 1 turning point. So 1 less turning point than the degree of your polynomial. All right, and up here, just so that this makes sense to you, so a turning point, okay, is where the graph changes from increasing to decreasing. Okay, so any place your graph changes from increasing to decreasing, that's a turning point. But what most people do is they look for max and mins, because wherever a max or min is, that's also a turning point. Okay, so let's look at this first example. This is just to make sure you understand these definitions up here in the theorems. So here's a sketch of a polynomial. First thing I notice about this polynomial is that the right end behavior is going up to positive infinity, and the left hand behavior is going to negative infinity. And remember, if the end behaviors are opposite, then this means that this polynomial is an odd degree. Okay, so just by looking at that, I know that. Then I also can see here's a relative max here, here's a minimum, there's a maximum, and there's a minimum. So that's what this last definition was telling you, is those are going to be our turning points. So you can also look at it from going from increasing here to decreasing down. So where it changes from increasing to decreasing, that's a turning point. So there's the first one. Then go from decreasing to increasing. So here's another turning point. So that's the second one. Here would be the third turning point. And lastly, went from decreasing to increasing, so 4. Okay, so this graph has 4 turning points, which again you can look at their these are relative maximums, and these would be relative minimums, so those are your turning points. So you can do it either way, whatever makes more sense to you. So the number of turning points in this graph is 4. So what is the possible degree? So from this theorem up here, the degree is going to be 1 more than the turning points. So if there are 4 turning points, the degree has to be 5 or bigger. Now, it could be 7, it could be 9, okay, those are other possibilities, but it has to be at least 5 because the degree has to be 1 more than the number of turning points, okay, at least 1 more. So why can't it be 6? Well, that's because of the graph. Since the end behaviors are doing the opposite thing, then remember this degree has to be odd, and it can't be 3 because this was 4. Okay, so these kind of go hand in hand, just so that that makes sense to you. All right, so with this theorem, a polynomial can have no more zeros than its degree then this third question here is asking what is the maximum number of zeros that's possible in a fifth degree polynomial? Well, that would be 5. That doesn't mean you're going to get 5, but that's the maximum that you can have. So this is important because a lot of you mix this up. So the number of zeros possible is the same as the degree. The number of turning points would always be one less than the degree. Okay, so be careful with those questions. Now this question is asking you what are the actual number of zeros in this graph? Well, that's just where it crosses the x-axis. So here's 1 0, 2 zeros, 3 zeros, and then nothing else crosses. So this graph, even though it could have 5 zeros, it only has 3. Okay, so that's important to know. But you don't always get the max. Sometimes it's less. All right, and then the last thing is the sign of the leading coefficient. So remember, anytime the right side of your graph is going up, that means the sign of your leading coefficient is going to be a positive number, right? It's going to be a plus sign. Okay, and that's because, I'll just put here, because the right side end behavior is up. Okay, so when the right side goes up, the leading coefficient has to be positive. Okay, so that was just so that you understand those definitions on that first page. All right, so let's look at the next page, which is a little bit more of some information on graphing. So let's talk about that. All right, we touched on multiplicities back in section 5.1. Okay, we talked about the odd multiplicities cross the x-axis, the even touch. So this is just a kind of going back over this a little bit more and then adding what Hawks likes to call flattening out. Now, in or on your final exam, this is not a word or words that we use, but it is in Hawks. So I wanted to mention this as we go through this one more time. So we're going to add a couple of these problems in here. All right, so let's just remember about multiplicities. Okay, so if f of x is a polynomial function, and we're going to let c be a 0 of f of x. So remember, if c is a 0, that's just some number, then that means that's where it crosses the x-axis. So that means there's an ordered pair, right? All zeros have an ordered pair of whatever the number is, c comma 0. Those are your x-intercepts. Remember, those are zeros, roots. You can call them all the same thing. And then it says, and x minus c is the factor. Okay, so we already know that. We've been working with factors and roots a lot. So then it says, furthermore, let x minus c to the k power be a factor of the polynomial where x equals c is the 0, and then the multiplicity is k. So again, we did this back in section 5.1. So if k is 2, then it has a multiplicity of 2. K is 3, the multiplicity would be 3. Okay, so go back and look at your notes on 5.1, but we did a couple of those already. So all of this is not new to you. So if c is a 0 of odd multiplicity, then the graph crosses the x-axis. Okay, and then your ordered pair would be c comma 0. We call these cross points, but for you, you just need to know that's where it crosses the x-axis. And then if c is a 0 of even multiplicity, then the graph touches the x-axis and turns back around. It doesn't cross. Okay, so hopefully you remember doing that, but again, we're going to do a couple more today. And again, the point C0 is called a touch point. So you either have points that cross or points that touch. Now, what Hawks will add into your questions is about flattening out. So as long as your multiplicity is greater than 1, then that means the graph will flatten out. Okay? So it's pretty simple to do. If your multiplicity is 1, then no, it doesn't flatten out. If it's anything bigger than 1, 2, 3, 4, so it doesn't matter if it's odd or even, okay? Any number greater than 1 is flattening out. So just to make clear on that, remember if your multiplicity is 1, then it just crosses, okay? So if you're looking at a graph where the multiplicity is 1, okay? That would be a multiplicity that equals 1. Then this thing crosses the x-axis and it's not flattening out. If you look at a multiplicity of 2, that would touch, but it would turn around. Okay, so this has a multiplicity of 2, and it touches, but it also flattens out. Okay, so this is considered flattening out. So it kind of gets flat before it turns around. This one does not get flat, just keeps going straight through. A multiplicity of 3, a cubic function, goes like that. So this has a multiplicity of 3. It crosses, but it still flattens out. Okay, it flattens out before it crosses. So you can have a touch that flattens out, you can have a cross that flattens out, and you can have a cross that doesn't flatten out. But any multiplicity greater than 1 will always flatten out. Okay? So you're going to be asked that on some of your Hawks questions, so I just want you to be aware of that. All right, now I'm not going to go through all these steps with you on how to graph a polynomial. We're going to do this together on the next few pages. But what I will tell you is that in Hawks, you're not asked to graph much. And I want you to understand that knowing how to do a graph is real important, because that really means that you understand all of these concepts. So if you can do the graph without your calculator based on this information, then you really have polynomials down. Okay, so we're going to go through this on these next few problems just to make sure that you understand this. So again, I'm not going to read this to you. You can do all of this yourselves, but you'll see how it goes on the next few pages. All right, so let's start with the second example. So look at what we're going to do. I know there's no directions here, but we're going to answer all these questions. So these are things we've been learning along the way. Okay, so I'm going to ask you what's the leading term, the degree, the maximum number of turning points, maximum number of zeros, what's the y-intercept, the end behaviors. We're going to talk about the zeros, their multiplicity, whether they touch across the x-axis, whether or not they flatten out, and then we're going to graph it. So this is those steps on that last page, 1 through 6. All of this stuff will help us graph. All right, so in example 2, things are already factored out. Okay, so you're either going to get a polynomial that's completely factored out, like this one, or if you look at example 3, you're going to get a polynomial that's not factored out. Well, when you have it this way, the leading coefficient and the y-intercepts are easy to find. When you have it this way, remember we did this back in section 1, you have to figure out what would be the leading term if you multiplied all this out. So to find the leading term, remember that you take each of the first terms in each factor, including the exponent, and multiply those together. So for our leading term, we would take the 2, and then x would be to the first power, because there's no exponent here, times x, and then this x would be to the 4th power. So those would be the first terms. This is a first term, that's a first term, and not just x is the first term, but remember we would have to multiply this out, so that would be x to the 4th. So 2 times x to the 4th would be 2x to the 5th. That's your leading term. If you were to multiply all this out, that would be the highest degree, the leading term. Okay? So the degree of this polynomial is 5. All right, that's the degree. The maximum number of turning points, remember it has to be 1 less than that, so that has to be 4. The maximum number of zeros can be whatever the degree is, so we could get 5 zeros. All right, now the y-intercept, you have to figure out, that would be the last term, the constant term. Okay, so you could multiply all this out, the last terms, or remember when you're finding the y-intercept, I'm going to write down here, you let x equal 0. Right? That's how you always find the y-intercept. So if we just let x be 0 here, we can figure that out. So I'm going to do my work for the y-intercept here. Okay, so let all these x's be 0. So that would be 2 times 0 plus 5 times 0 minus 3 to the 4th. Okay, so that would be 2 times 5. 0 plus 5 is 5. 0 minus 3 is negative 3 to the 4th. So negative 3 times negative 3 times negative 3 times negative 3 is a positive 81. and now we can multiply 2 times 5, which is 10. 10 times 81 would be 810. So that's your y-intercept. Okay? Now, if you did it the way I did the leading term, you would take the last terms. So you do 2 times 5 times negative 3 to the 4th, which is exactly what we did right here. Okay? But I always like to remind you to find the y-intercept is just as easy to let all the x's be 0. Okay? So if you ever get stuck on that, that's how you do that. All right, end behavior. Since the leading coefficient is positive, I know the right side is up. And since the degree is odd, I know these two have to be opposite. So that means the left side would be going down. Okay? All right, now let's look at our zeros. Remember, if there's just a number out front, that's not a zero, that's a constant. Okay, you only get your zeros from terms with x in it. So that's just 2, it's not a 0. Then x plus 5 is a factor. So if you set that equal to 0 and solve, right, you end up with negative 5 as your 0. So there's your first 0. And then x minus 3 is a 0. Set that equal to 0 and solve it. You get 3. So there are my 2 zeros. Now, what are their multiplicities? Well, x plus 5 is to the first power, so it has a multiplicity of 1. And x minus 3 is raised to the 4th power, so it has a multiplicity of 4. When you're doing touching or crossing the x-axis, remember odd multiplicities cross. Even multiplicities will touch and turn around. And then flattening out is anything bigger than 1. So it's not going to flatten out at negative 5 because the multiplicity is 1, but it will flatten out anything bigger than 1. So it's going to flatten out at 3. Okay? All right, so once we have all that, now we can do the graph. So we can plot our y-intercept. So I know this is not to scale, but here's 810 way up there. It's the y-intercept. You have a 0 at negative 5, and you have a 0 at 3. Okay. All right, now you're going to start with your end behavior on the left, which I know has to be going down. I'm going to touch or cross at negative 5. So when I look at negative 5, I'm going to cross, right? It had a multiplicity of 1. And then I got to come up here and hit that y-intercept. So it's going to cross, it's going to touch that. Now, what's going to happen at 3? It has a multiplicity of 4, which means it's going to touch and turn around. And remember what the right side has to be doing. It has to be going up. Okay. Now again, that is not to scale, so that's not exactly what it would look like. Now you put this in your calculator, you're not going to see 810. You'll see this line go up and you'll see it come down, but you're not going to see this. Okay. You'd have to do some zooming out in order for that to happen. But again, this is just a sketch, and it gives us some good information on your graph. Okay, so knowing how to do this really means that you understand all of this. Now look, you only had 2 zeros. We could have ended up with 5 zeros, but just so happened we did not. And there really are 5 zeros because of this multiplicity. Okay, x minus 3 is really happening 4 times, right? This is x minus 3 times x minus 3 times x minus 3 times x minus 3. So that's the multiplicity. So it's taking up 4 of the 5 roots that you could get. And then here's the other one. So when you actually look at your multiplicities, they will add up to the degree of your polynomial, which is kind of why that happens, okay? So there's that first one. All right, so now we're going to look at example 3, which is not factored out, which makes some things easier, some things not. So let's talk about that, because we're all going to have to factor it. Okay? All right, so first thing, when we have a non-factored, so the polynomial is just in standard form, the leading term and the y-intercepts are the easy ones to find. So the leading term is the highest power you see, and then remember the y-intercept is always that constant term at the back. If you don't remember that, you remember you let all the x's be 0. So if this is 0 and this is 0 and this is 0, then you're going to end up with 80, right? So there's your y-intercept. Okay, so the degree of this polynomial is 3, okay, highest power. The maximum number of turning points can only be 2, and your maximum number of zeros would be 3. Okay, so this is important that you know that based on your polynomial. And behaviors, again, the leading coefficient is 1, so that's a positive number, so the right side's up. And because it's an odd degree, left side is down. So it's going to look similar to the one we just did. Now, what's not easy to find on a problem where you don't have factors are the 0. So we need to figure out what the zeros are, so we have to factor this out, okay? So, since there are 4 terms, typically we do that by grouping. So I'm going to group the first 2 terms together. And remember, when you group, this always should be a plus sign, okay? Well, I take that back. Well, yeah, let's put a plus sign in there. So we're going to make the negative 16 go in there, right? So we want to start off with that plus sign. And then we want this term to always be positive. So when we factor, we're going to factor out a negative. All right, so remember grouping. Look for what's common in just each group. So in the first group, these two have an x squared in common. And if you factor out an x squared, it leaves you x minus 5. What do these two have in common? Well, both of them, 16 is a factor, but I don't want this term to be negative, so I'm going to factor out a negative 16. So if you divide both of these by negative 16, this is going to leave you x, and 80 divided by negative 16 will leave you minus 5. And remember, in order to group, you want these two to be the same, which they are. Okay, so we're going to continue to factor. So that's one of the factors, x minus 5, thing that's the same. And then you group the 2 outside terms together to create your second factor. So x squared minus 16. Okay, that groups together to give you your other factor. Now we're not quite done because this can be factored again. This is a difference of squares. So I'm going to put equals. So I've got x minus 5. And then x squared minus 16 factors x plus 4, x minus 4. Difference of squares. Alright, so now I see my zeros. Okay, remember, set each of these equal to 0 and solve. So if you set x minus 5 equal to 0, you get 5. Set x plus 4 equal to 0 and solve, you get negative 4. And set x minus 4 equal to 0, you get 4. Right? So find your zeros, and you don't have to do that. Hopefully by now you're realizing they are the opposite signs, the zeros and the factors. All right, each of these are to the first power, so each of these have a multiplicity of 1, which means every one of these are going to cross the x-axis. Okay, they all have odd multiplicities, and none of them will flatten out, because you only flatten out if this is greater than 1. Okay. All right, so we're ready to graph. Now, our y-intercept is still crazy up here at 80. It wasn't 800, but it's still 80. And then we're going to do negative 4. Okay, and then 4 and 5. All right, so remember, we're crossing at each of those values. We have to touch here, and we'll always start with the left side, so we're going to be down. So here's, let me put some points in there for the roots. Alright, so we're going to go through here, touch there, and then I got to cross and come back and cross again. Now I don't know how far down this goes. You know, if you graph it, you'll get a better idea. This is, again, just a sketch. But look at this. I have a turning point here, right? Here's a max. So this is a turning point, and then there's a turning point. So it had 2 turning points, which is what we said. This one did have 3 zeros, so that was our max number of zeros. Okay, so all of those things hold true for this problem. Okay. All right. So when you go back to those steps on page 2, before we do the last one, okay, this is everything we're doing. We did the end behavior, we found the y-intercept, we found the zeros, their multiplicities, we plotted everything, And then remember, it says draw the sketch starting from the left, right? The left end behavior. And then we connected and did everything. Now number 6 says plot more points if you need better accuracy. So if you're in Hawks and it needs an exact graph, well, then you probably want to pick a point over here to kind of know where it is. You want to pick a point down here to know where, where it is. So I'm just giving you the sketch. I'm not plotting points. So that just depends on accuracy. Okay, how much you're asked to find. All right, let's do one more of these, and then we got a couple more problems to look at. All right, so on this one, it's factored. Okay. So to find the leading term, we got to do multiplying the first terms, including those exponents. So to find the leading term, I would multiply 8x, and then remember x squared. And then be careful, this would be 2x, all of that raised to the 5th. So I got to do some work there. It's not just 2x to the 5th. I got to raise 2 to the 5th and x to the 5th. All right. So I'm going to leave the 8x and the x squared by itself for a minute. So what is 2x to the 5th power? So that's 2x times 2x times 2x times 2x times 2x. So that would be 32x to the 5th. Okay, 2 to the 5th power is 32, x to the 5th. All right, so now I can multiply. So 8 times 32 is 256. Then add your exponents, so 1, 3, and 5 is 8. So there's your leading term. Okay, so please be careful that. Remember, this is 2x plus 7 times 2x plus 7 times, right, 5 times. So you're multiplying 2x times 2x, you're multiplying this 5 times, not just this and then put a 5 at the end. That's not, be careful with that. All right, so the degree of this problem is 8. Maximum number of turning points would be 1 less, and we could get up to 8 zeros. All right, the y-intercept, this would be one where you would let everything be 0, and then that's going to be pretty easy to tell because 8 times 0 is 0. Okay, so 0 minus 1, negative 1 to squared. This would be 0, 2 times 0, 7 to the 5th, but it doesn't matter because you got 0 times whatever's here. So 0 times anything is just 0. Okay, so it doesn't really matter. I mean, I could put all these zeros in here, but the fact that this is 0, 0 times this is still 0. All right, and behaviors. This is an even degree polynomial. Leading term is still positive, so that still means the right side's up. But now because it's even, also means the left side's up. Remember, even has the same end behaviors. All right, so our zeros. This has an x in it, so it is a 0 this time. So if you say set 8x equal to 0 and solve that, because remember, every term that has an x in it is a 0. Set it equal to 0. When you divide by 8, you get 0. X minus 1, set that equal to 0 and solve, you get 1. And then 2x plus 7, you get a fraction or decimal, however you want to think it. Set it equal to 0. You get 2x equals negative 7, so x is negative 7 halves. You can leave it like that. Write it negative 3.5, doesn't matter. Okay, whatever's easier for you. All right, multiplicities. 8x is to the first power, so it has a multiplicity of 1 at 0. X minus 1 is squared, so it has a multiplicity of 2. And 2x plus 7, multiplicity of 5. All right, so 1 is odd, it will cross. 2 is even, so it will touch. 5 is odd, so it will cross. Flattens out anything bigger than a multiplicity of 1. So 0, it's not going to flatten out, but here and here it will, because those multiplicities are bigger than 1. Okay? All right. So y-intercept this time is 0, which is also one of the zeros. So we're going to just plot 1. There's another 0, and negative 7 halves right back here. Right? All right, So we're going to start up high. Now at negative 7/2, we're going to cross. But remember, it flattens out. And then at 1, we're going to touch. And at 0, we're going to cross. Okay? So this one, you know, drawing it, you just got to be a little bit. So it basically, so we're starting up here, start on the left side. So it's going to kind of flatten out, but still cross. So something like that. Okay, and then I got to turn around and come to 0, and at 0, I'm going to cross. So, and then I got to turn around again, and this time at 1, I'm going to touch and turn around. So, got to turn around. Not the prettiest of graphs, but notice the right side is also up. Okay, so my end behaviors have to look like that. Okay. All right. Now, I want to mention to you in Hawks a couple of questions. So in Hawks, you're going to be asked these kind of things, but then you're going to be asked a question kind of like how many zeros cross the x-axis. So like in this question, how many of these zeros cross? You would say 2. Okay, 2 of the 3 cross. And then it's going to ask you for the ordered pairs of those points. So the ordered pair for this 0, remember, would be 0, 0. The ordered pair for this 0 would be negative 7/2, 0, right? So if they ask you for the ordered pair in Hawks, remember this is the x-coordinate, and then 0 is always the y-coordinate for any of your x-intercepts. It might ask you for how many of these zeros flatten out. Well, in this question, how many of these 3 zeros flattened out would have been 2. Okay, these 2 flattened out, this one did not. And same thing, it's going to ask you for the ordered pairs. So this would be 1, 0, negative 7/2, 0. Okay, so that's a little bit different in Hawks. Again, we don't do the flattening out, you know, for the final or what the math department wants, but I want to make sure you understand what Hawks is asking you for. Okay, so you might see a question on how many of the zeros cross and how many of the zeros flatten out, and also they want you to give it in ordered pair form and not in, you know, just what x is. Okay, so this would be the ordered pairs for the zeros. Okay, all right, so hopefully that won't mess you up, but just so that you understand it and see it before you actually get to that problem. All right, last couple problems. Example 5 just kind of puts everything all together again. I think we did this back in section 1 or 2 already, so I just want to go through this, make sure, because in Hawks you can't give decimals sometimes, you have to give the radicals or the exact answers. So let's talk about how we would find the solutions to this. So first off, I can't have a polynomial that's not equal to 0, so I need to move everything over to one side or the other. Now I know there's more terms on this side, but I always want my leading coefficient to be positive when at all possible. So I'm going to move these 3 terms over to the left. So I'm going to leave the x to the 4th there. And then I'm going to put this in descending order. So I'm going to move the 16x to the 3rd over. So that's going to make it minus. I'm going to move the 22x squared over, which is going to make it minus. I'm going to bring the negative 80x over, so it's going to become positive. And then I already had that plus 85 there. Okay, so just remember, whenever you move things over, terms over the equal sign, they just change. And I just put this in descending order because I need to do synthetic division in a minute. All right, so typically, if I didn't have a calculator, I would have to use the rational roots theorem and come up with all the possible rational roots and figure out, you know, which one is a solution. But because I have a calculator, we're just going to graph this and see what happens. Okay. So I'm going to put this into y equals, so you can do that with me or just watch. So we've got x to the 4th minus 16x cubed minus 22x squared plus 80x plus 85. Okay, now when I graph this thing on my regular window, okay, I don't see a whole lot of this graph. Now it's fourth degree. I know both ends are up, okay, but I'm missing some things. But what I'm trying to do is find a root that looks like a whole number. That's all I need, is one root that's a whole number. So this doesn't quite look like it's crossing at a whole number, but right here that does. That looks like -1. This is not negative, this is not a whole number right here. So I'm going to start by looking at this graph and starting with my assumption that -1 is a root. Okay, so I'm just going to write here by graphing. Looks like x equals -1 is a 0. Alright, so how do I check that? Well, I'm going to do synthetic division and make sure that my remainder is 0. Okay, so I'm going to put what I think is a root and I'm going to divide that. So I'm going to put my coefficients. So this is why I put these in order. And every exponent is counted for, so I can just put the coefficients. Okay. And I'm going to bring down the 1. And I'm going to start doing my synthetic division. Okay, so 1 times -1 is -1. Add those, it's -17. -1 times -17 is a +17. Add that, I get -5. -5 times -1 is +5. Add that, I get 85. 85 times -1, -85. And I get 0. So this is definitely a 0. Now remember, it said find all the solutions. So there's one of them, -1. Okay. Now I got 3 more to find, most likely, because this was x to the 4th. So remember, this is your new polynomial, and it's going to start 1 degree less than this one. So this will be 1x cubed minus 17x squared minus 5x plus 85. Okay. Now, the other roots didn't look like whole numbers, so most likely they're either going to be radicals or fractions, so that's hard to find on the calculator if I need an exact answer. So I'm going to factor. Anytime I get down to x to the 3rd, I can factor. So just like I did before, I'm going to do grouping. Okay, keep that plus. So keep that term, that sign with that 3rd term. Now what can I factor out of here? I can factor out an x squared, leaves me x minus 17. I need to factor out a negative number. Both of these have 5 in common, so factor out a -5. And if you divide both of these by that -5, this will turn into positive x. And divide 85 by -5, we get -17. So remember, we're grouping, so this is one of your factors. And then this gets grouped together, so x squared minus 5. All right, now remember, we already had the x, the -1, so that would have been x plus 1, right? That was one of my roots, so that's part of it. Didn't ask you to factor, but I'm just showing you. All right, so we already knew that -1 was a solution, so set these guys equal to 0 and solve. So x minus 17 would give you 17, so there's another one. And then when you set x squared minus 5 equal to 0, remember, x squared will equal 5. So x is plus or minus the square root of 5. Okay, so there's 2 more. So all your roots were -1, 17, square root of 5, negative square root of 5. So I ended up with 4. And remember, that's the total number I could get. So all of them were different. Now, again, if you're doing this on your calculator, these are going to be irrational numbers, and Hawks might not like you to put in the decimal rounded, so you have to know how to do these by hand. But this is typical of the way that you do that. Always they're going to give you a problem where at least one of the roots is something you can find on your calculator. And so you start with that, and then you break it down from there. Okay? All right. So there was the answer to that. Okay, and lastly, again, we did this in section 5.1 or 5.2, I can't remember. But this now adds a little bit more. So remember, we were constructing polynomials. So given the information, can you write the polynomial? All right, so First thing is it's third degree. Okay, so I can't have anything higher than x cubed. That's my power. It says 4 is a 0 of multiplicity 2. Well, if 4 is a 0, that means x minus 4 is the factor, and it has a multiplicity of 2. It says negative 2 is the only other 0. So if negative 2 is a 0, that means the factor was x plus 2, right? Remember, they're opposite. And then the leading coefficient is 3. All right, so I have to multiply all this out and come up with a correct answer. So I'm going to leave that 3 out there for a minute, and I'm going to go ahead and square this. X minus 4 times x minus 4. Remember, you're foiling, right? That's not just x squared plus 16. You got to FOIL this out. So first is x squared. Outer is negative 4x. Inner is negative 4x. That's negative 8x. And then last is positive 16. Okay. All right. Now, I'm going to still leave that 3 there. And I'm going to multiply these. So I've got to multiply x squared minus 8x with 16 times x. And then I'm going to multiply those 3 things by the 2. So I got to do each of those. So x squared times x is x cubed. Negative 8x times x is negative 8x squared. 16 times x is 16x. And I'm going to go through these 3 times 2. So 2 times x squared, 2x squared. 2 times negative 8x is negative 16x. 2 times 16 is 32. And again, before I do that 3, I'm going to add my like terms. So there's no other x cubed. But I've got a negative 8x and a positive 2x squared, which is a negative 6x squared. I've got a 16x and a minus 16x, which is 0, and then plus 32. Okay, so I just added. I'm making it a little bit easier. And you could have multiplied the 3 through first, but I just like to leave that out there. And lastly will be to multiply the 3. So 3x cubed minus 18x squared plus 96. So there would be a function who has a root of 4, a root of negative 2. It's third degree. Okay. So just follow with what they give you, and then you do need to multiply it out. So just be careful on your algebra. And again, you could have multiplied the 3 here first and done 3x squared minus 24x plus 48. But see, then the numbers are starting to get too big, so I like to kind of just work with the smaller numbers first as I can. But you would have got the same thing if you did it that way. Okay? So that's just my choice in doing it that way to kind of make it easier on me. Alright, so that does it for section 5.4. So we'll work on Hawks. Let me know if you have any questions, and I'll see you back here next time.